Hi everyone. In this video, I'll cover all the key pointers that you must have on your fingertips in order to perform well in any P3 integration question. And then I'll also show you the integration roadmap that will help you decide which technique to start your question with whenever you are confused. Of course, if you are someone who have done quite some practice of integration, this will never be a question. But let's say if you are starting integration a bit late and your exams are on the way, in that case, this roadmap will be pretty helpful for you to understand and decide which technique to use when. But first things first, just like I had mentioned in the chapter of differentiation, which I had explained previously, I had mentioned that how important it is for you to understand and practice the manipulations and master them with respect to trigonometric, algebraic, logarithmic, and exponential functions. The same thing also repeats over here in integration. If you are good with all the manipulations, only then you can solve all the questions of P3 integration comfortably. Because if you're having all these key pointers in your fingertips or on your fingertips, then doing the integration becomes easy after this point. But then the manipulations is where a lot of students struggle. But yes, with the help of a lot of examples, as you can see over here, I'm going to go through 8 different types of common questions that you can expect in your P3 integration. And then I also show you two unusual questions, according to me, that came up in the past papers. And this is going to help you strengthen your concepts of P3 integration. And then you can keep on practicing as much as possible to master the concepts of integration. So the first key pointer is you must know how to integrate the bare minimums that I'm highlighting on the screen. You should know that the integration of the exponential term is exponential term. You should know that the integration of the reciprocal term will be in form of ln. You should know that the integration of sine will become minus cos, cos will become sine, sec square will become tan. And along with that, you should also be good with the reverse chain rule. What are the do's and what are the don'ts that you have learned in your AS level? For example, if you are having sine of ax plus b to integrate, I know that the integration of the sine will become minus cos, and then I keep the input as it is without changing it. Then according to the reverse chain rule, I am having the inner function which I did not do anything about. So I need to take the derivative of the inner function and divide it. That is what we have learned in the reverse chain rule in your AS level. But what is the do's over here? The do's is that whenever you're going to take the differentiation of the inner function and when you're going to divide it with the integration, like what I've done over here, it should not have a variable along with it. If there is a variable, then that is a don't. If you are having a variable which is not getting cancelled out anywhere, in that case, reverse chain rule is not applicable. In that case, you need to think about something else. So these are the pointers that you must be aware about in the reverse chain rule. Let's talk about when the x in the bottom would be valid. Let's say if the question was sine of a x square plus b, which is also multiplied with another x. It is like, integration of x into sine of ax square plus b dx. In that case, how would you integrate it? I know that it will become minus cos of the same input, that is ax square plus b, but divided by the differentiation of this, which will become 2ax. Now, if this x is coming in the denominator, and I can see that there is another x given to me in the question itself, this simply gets cancelled out. This is allowed in the reverse chain rule. But let's say if your x was not getting cancelled out and you are still having x in the denominator, you must know that that is incorrect and you have to on the spot think about some other method. I hope this is clear to you. These were the just bare minimums that you should be aware about with respect to reverse chain rule. Now, the second key pointer that you must have on your fingertips is the integration of ln functions. Whenever you are having an ln function to integrate, you must remember that you can multiply this with 1. Then differentiate the ln term, integrate the 1 term, and apply the integration by parts rule over here and solve this integration. Then comes the next key pointer, that is the integration, and the result will be in the format of tan inverse. I know that there is a formula given to you in the formula booklet with respect to this, but it does not involve this complicated thing that I've written over here. So it's better to master this as compared to the rule that is given to you in your booklet over here. This is the rule, I think. Let me see where it is mentioned. Yeah, this is the rule that is mentioned over here. That if you integrate this, you get tan inverse of x. But if I am having something more complicated than this, I know that students do struggle in that cases. That is why I've written this specific formula. Always first think about that if you can convert your fraction in the format of a square plus something in form of x, can you take a square of it? If it is in this format, then the answer will always become 1 over b into a times tan inverse of bx over a. So yeah, if you're aware about this rule, it's pretty good. In the examination, you won't be struggling with this kind of questions. I'll even show you some of the practice examples as we go ahead. Now the next key pointer is, if we are having to integrate a fraction which is in the format of f dash x over f of x, which is, let's say if you're having a fraction in which you are having a function in the denominator and its respective derivative in the numerator, or let's say by taking simply the derivative of the denominator, you can't get exactly what is present on the numerator. Let's, you need to multiply or divide with some kind of a number to get it exactly in that format. That is why I've written k outside. So once you're having that particular format where you can see that exactly the derivative of f of x is present in the numerator, in that case, output will 100% become ln of modulus of f of x plus c, of course. I have seen a lot of times students forget to write the modulus sign, which is not true. Why it is not true? Because sometimes f of x can become negative. And we know that ln of a negative number does not exist and it will become a problem. That is why having a modulus sign outside the function is very important, that even if there is a negative number, because of the modulus, it will become positive and then ln of that positive number will be taken. So that is one important thing, that don't forget to have a modulus sign. I'll also show you the example with respect to, let's say, tan x, tan of ax plus b, let's say in this case. So if I'm trying to integrate tan of ax plus b with the help of this rule, you can also apply this, by the way, for the cot of ax plus b. Like this, there are a lot of examples. Of course, you must be aware about it if you have practiced with respect to this rule. But yeah, let's say for now I have to integrate tan of ax plus b. I can convert this into the format of sine of ax plus b divided by cos of ax plus b, so that it's in the fraction format. And I know that if I have to integrate with respect to x, the derivative of cos of ax plus b will be what? It will be minus sine of ax plus b multiplied with a. So I know that there is a constant of minus a which is missing in the denominator. So in the denominator, what kind of thing can I do? I need to have minus a somehow. So if I'm having a minus a over here, it cannot come randomly from anywhere, right? I also need to divide it with minus a. But yeah, now it's in the format of what you see over here. The derivative of cos of ax plus b will become minus a sine of ax plus b. But along with that, you are also having the k outside, that is 1 over minus a. This was the manipulation that I was talking about, that you might have to multiply or divide with some kind of a number, and there you go. That's how you do it. Now, integration will simply become minus 1 by a times ln of modulus of cos of ax plus b plus c. That is how you can simply deal with this kind of questions. You can apply the same logic and try to integrate cot of ax plus b completely by yourself and see if you are getting the correct answer or not. And then what you can do is you can comment the answer of the integration of this and I'll tell you if it's correct or not. Okay. Moving on to the next key pointer, you are supposed to integrate the terms such that there is a multiplication involved. And in this multiplication, if you are trying to integrate one of the term using the reverse chain rule, there is a variable that is coming in the denominator which is also present in the numerator. So what is going to happen in this case? The f dash x in the numerator and the denominator will simply get cancelled out. This is the example that I was talking about when I was integrating this in the first rule, that if you had to integrate sine of ax square plus b, which is multiplied by x, how would we do this? I told you that you can apply the reverse chain rule over here. You can integrate this term, which will become minus of cos of ax square plus b, and then divided by 2ax, and then there is also x present over here. You don't do anything to this x because this x will simply get cancelled out with the x in the denominator. Now this is 100% valid and this is coming from this particular rule. Over here you saw that I am not using n plus 1 rule, because without the n plus 1 rule also this was making sense. But let's say if you are having f of x to the power of n, you can also apply the same trick with the help of n plus 1 rule also, because reverse chain rule is also applicable in this kind of formats. And one of the common type of example that they have been repeatedly asking in the past couple of sessions, I think from 2025 onwards, I have seen at least one question with respect to this kind of integration. So I highly recommend that you are following how to integrate with respect to this rule without directly doing the u substitution method. If you're aware about this kind of rule, you can do this integration in just 5 seconds. But yeah, with respect to U substitution integration also, it's not incorrect, it's just a bit time consuming. So yeah, let us try to integrate the term over here in the example. If I'm given cos of x into sine square x, I need to think about, if I integrate the cos x, it will become what? Sine x, that's it. But if I get the sine x, then I am having sine square x as it is, which is just lying over there. So this is not the correct way to integrate. So let me think about, if I integrate the sine square x term, in that case, what's going to happen? If I integrate the sine square x, it will become sine of cube x divided by 3. But then you're also having the sine x term over here, which you did not do anything for. The n+1 rule was applied, but then you forgot the sin x terms differentiation in the bottom, because that is the reverse chain rule that you've learned in ES level. So that will simply become cos x. The derivative of sin x is cos x. But now you can never have a variable in the denominator. But in the question itself, there was a cos x. So you can just carry forward that cos x, and this cos x will get eliminated with this cos x. So this is 100% a valid answer over here. You could have done the same thing with respect to the U substitution, but you would say that it will always take much more time as compared to how you can easily do this without spending a lot of time over here. And this is 100% valid. So yeah, I hope that you are going to practice this kind of questions a lot, because I am very much sure the probability of getting this kind of question is very, 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 very high. In May, June, I mean, sorry, in Feb, March, okay, in Feb, March 26, there were two questions with respect to this rule. Just imagine, in one paper, two such questions. And people were struggling just because they were not aware about this kind of rule in the first place. So I hope this is clear to you, how to use f dash x into f of x, or let's say even this kind of a function where you're not having a power, but then when you are going to integrate this kind of term and in the denominator you're getting a variable, the variables can simply get cancelled out if it is also present in the numerator inside the integrand. So yeah, if you're willing to practice more such kind of questions, you can let me know in the comments. I'll create a separate video for the same. But for now, I am assuming that this kind of rule is clear to you all. Moving on to the next type of question, where you're supposed to integrate the terms with respect to sine square and cos square alone. Why am I saying alone? Because let's say if we are supposed to integrate sine square x along with the cos. Sine square is not alone, but cos is along with it. In that case, you can use this kind of rule and it becomes very easy to do this. But then let's say integration of sine square x alone is what you are doing, then it becomes a bit tricky, because along with that, there is also a tricky question of cos square x. So in this kind of questions, you cannot use sine of cube x by 3 into cos x, because this cos x cannot be cancelled with anything on the numerator. And that is why this is not the correct way to integrate. I told you, you need to think about an alternative technique. The alternative technique is coming from the manipulations of the double angle of cos. That is, you should be aware about how to integrate sine square x and the cos square x with respect to cos 2x formula. Let me give you an example. If we are supposed to integrate, let's say, cos of 2x, I mean cos of half x, cos square of half x dx. In this case, how would you integrate this? We will use the double angle formula. Cos of 2x is equal to 2 cos square x minus 1. And then because I know that cos square is having an angle that is half angle, that is x by 2, I can divide both the sides of angle by 2. Remember, I'm not dividing the entire equation by 2. I am just dividing the angles by 2 on both the sides. So from here, I have derived a formula. Cos of x is equal to 2 cos square of half x minus 1. And now cos square of half x, I can simply make the subject of formula, so that it becomes cos x plus 1, that is whole divided by 2. And now you can integrate this in place of cos square of half x, because you know how to integrate cos x term, you know how to integrate the 1 term. So yeah, this is the manipulation of the double angle of cos that you must know in order to integrate cos square of some kind of term or sine square of some kind of term. The next step of integration is with respect to the manipulation of the double angle of sine. Let me give you an example. If you're supposed to integrate, let's say, 8 sin x cos x. Oops, yeah, 8 sin x cos x. How will you integrate something like this? So you can solve this in two different ways. The first one is utilizing the formula of sine 2x, and the second one is the extended n plus 1 rule that I was talking about earlier. Let me show you with both the methods, starting with the extended rule of n plus 1. So over here, either you could integrate sine x and convert it into sine square x over 2, or you could have integrated cos x term and convert it as cos square x over 2. Of course, then you also have the derivative of the respective cos x or the sin x depending on what you want to integrate. But in either of the ways, you will get the same answer as doing the integration with the help of sine 2x formula. So yeah, I'll show you both the methods and compare the answers, and you can realize that yeah, with both the techniques, you're getting the same answer. So over here, let us think about integrating cos x term. Of course, I know that the cos x integration will become minus sin x. I mean, sorry, positive sin x. But then if you are integrating this and you're not integrating this, then that's incorrect. So that is not a direct integration that you can do for the cos x. Instead of that, you can consider cos x as cos x to the power of 1 and use n plus 1 rule over here. So this is same as writing cos square x over 2. And then what is the differentiation of the cos? It is minus sin. So just write minus sin x in the denominator. And why it is valid? Because you are also having 8 sin x in the top. So this sin x and this sin x gets cancelled out. So at the end, eventually you are having minus 8 cos square x. Sorry, 8 by 2 is 4, right? So it's going to become minus 4 cos square x plus some integrating constant. Let's call it C1. Why did I call it C1? There is a logic behind that. I'll explain that to you in a while. Now, let me integrate the same thing with the help of sine 2x formula. For that, let me use another color. Let's say in order to use the sine 2x formula, I know that my sine 2x is same as writing 2 sin x cos x. So how can I get 8 sin x cos x? By multiplying 4 on both the sides. So my 4 sin 2x is same as writing 8 sin x cos x. So if you want to integrate this, it is same as integrating the left hand side. So over here, I clearly know that the integration of 4 sin 2x will become, I know that integration of sine is minus cos. So this will become minus cos of 2x. And of course, there is a 4, so you write a 4 over here. And then there is also a division by 2 because of course you are using the reverse chain rule over here. So it will simplify to minus 2 cos 2x. You will tell that, hey Rohan, this format and this format is not same. Of course, there is an integration constant, let's call it C2. So this is also plus C2. So you are saying that this is not same. So in that case, what to do? Of course, I can still simplify this by opening the cos 2x by using the double angle formula for the cos. I know that there is a formula that relates cos 2x with the cos square x. So this is same as writing minus 2 is constant, so I'll just keep it outside. And the formula for the cos 2x is 2 cos square x minus 1. And then plus integration constant C2. Now, I can simplify it further and this will become minus 4 cos square x, which is what we had over here. And then plus 2 plus C2. Plus 2 and then plus C2. So you can see that this term and this term is exactly same. But then the integration constants are a bit different. There is no problem with that. There is no problem with that because this C1 could be 2 plus C2 or this C2 could be C1 minus 2. Either of that thing would be C. So integration constants are not a problem at all. So the answer over here you can see eventually you're getting the same thing irrespective of which technique you use. So that is one thing. But if you had to integrate sine square ax, cos square ax, in that case, how would you do it? Can I still use both the formulas or just I can use the double angle of sine? Let's try to think about that. But I hope that the integration of the sin x into cos x term with whatever constant is now clear to you. You could use either of the method and still get the correct answer. Now let's talk about how to integrate sine square and the cos square term that are multiplied together. For that, let me just erase all of this very quickly. So yeah, let's see if I have to integrate. sine square x cos square x dx. In this case, let's say if I have to use the extended version of the n plus 1 that is over here, let's say if I'm trying to integrate now this sine square x term, it will become sine cube x over 3 into the derivative of sine x, which is cos x. And this is multiplied with cos square x. You can see that this cos x is getting cut with this cos, one of the cos. You are still having sine cube x, which is multiplied with a term which is not integrated yet. So again, this is directly you can't do it. You haven't learned this kind of things in your reverse chain rule. So in that case, it will be very difficult if you are going to approach with the extended n plus 1 rule. You will not get the correct answer. So instead, what you can do is you can simply convert this into the sine 2x format. And then you can integrate it very easily and confidently that yes, my answer will be 100% correct. So how can you do it? I know that my 2 sin x cos x is same as writing sine 2x. Now if I just make sin x cos x the subject, it will become sin x cos x is equal to sine 2x over 2. Now I want to integrate sine square into cos square. So if I want to integrate sine square into cos square, I need to square on both the sides. So my sine square cos square will simply become 1 by 4 into sine square 2x. Now how to integrate sine square 2x? Of course, you are trying to integrate the left side. It is same as integrating the right side. So how do you integrate the sine square 2x term? So in that case, you can use the cos 2x formula. I know that my cos of 2x is same as writing 1 minus 2 sine square x. Now I know that I am not integrating sine square x, I am integrating sine square of 2x. So if I multiply my angle by 2, this 2x will also be multiplied by 2 and this will become 4x. So the formula over here would become sine square 2x is equal to 1 minus cos of 4x whole divided by 2. You can substitute the sine square of 2x, you can substitute the sine square of 2x, this formula over here, and integrate this because you know how to integrate the cos 4x term. So that is how you can integrate the sine square into cos square term with the help of sine 2x formula. So I hope that this is clear that whenever the sine and the cos are multiplied or their squared are multiplied, how you can integrate this kind of equations. Now moving on to the next part, how to integrate a polynomial fraction. There are two ways in which you can do this. The first form is remainder quotient format and the second one is partial fraction format. So let me give you an example to understand this. Let's look into the type 1 of the common questions in integration. We are supposed to integrate this. This is a fraction involving polynomial. So what you can do is in part 1 you are already given the quotient and the remainder. So you can convert this into the quotient remainder format. This is same as writing quotient plus remainder over divisor. This is same as writing polynomial in the numerator divided by the divisor in the denominator. This form is same as writing this form. How do we get this? This is coming from the chapter of polynomials. If you are having a long division of the polynomial, that can be expressed in the form of quotient times divisor plus the remainder. Now, if you multiply, or I should say divide both the sides with the divisor, so p of x will get the divisor over here. If you divide this with the divisors get cancelled out, and then the remainder will have the divisor. So I hope you are understanding how we got this format from this format. So now you know how to integrate just one polynomial or a polynomial over here. If I have to show you how we can do this for this specific question, of course you can see it in detail in the next video when I'll be solving this. But this is same as writing integration of 2x minus 1 plus 6 over x square plus 3. You just have to differentiate this with respect to x. So over here, this will be the tan inverse rule, and this is a very simple 2x minus 1 is very easy to integrate. So yeah, this is how you can solve this particular question. Let me see if I'm having an example of the partial fraction. Yeah, there you go. You know that you are having a fraction which you can convert into a partial fraction because directly you can't integrate this. So in that case, what you can do is you can convert this into the format of a over 3x plus 2, then plus bx plus c over x square plus 4, and then integrate this with respect to ln rule and integrate this with respect to tan inverse or again whatever kind of rule that suits you on the given occasion. But yeah, I'll show you this kind of question again in the upcoming videos in this series, so stay tuned for that. But this is the exact thing that I was talking about in this method, that if you are trying to integrate a polynomial fraction, there are two different techniques in which you can do this, depending on which format is given to you. Then comes the I method. I method for the integration by parts whenever the integrand is repeated in the method. And again, this is, I've never seen this kind of question asked in your final examination, but you can't risk of not knowing this particular method. They can toss this kind of things whenever they want. So if you're having, let's say, integration of e power of x sine x, in this case, what's going to happen once you're going to apply the integration by parts formula, you will get over here e power of x cos x format. Now, again, you will have to apply the integration by parts to integrate it further because there are two different terms. So one will be u, one will be v, which you need to integrate and differentiate. So after doing the integration by parts, once again, you will have something like e power of x sin x. So when you are saying that the same thing is repeated as you had in your question, what you can do is you can let this as I. So this is also I, this is also I. And then you can take i's on the same side so that it becomes 2i and everything else is on the right hand side. Now you can just say that I is equal to everything on the right hand side divided by 2. This will be your answer. If you are not aware about this kind of rule, I'll give you a link in the video of this description. What am I saying? I'll give you the link of a video for this kind of question in the description. You can go ahead and check that out, and I hope it will be useful. But yeah, the questions so far with respect to this method I've never seen in my experience so far in P3, but you should be aware about this. So yeah, I highly recommend that you check this video on how to use I method for this kind of questions. Moving on to the next part, U substitution is always evident in the question. They'll say that let U is equal to this, then convert the given equation into some different thing in form of U, and then later integrate this kind of thing. So this kind of questions are very popular. So this kind of questions are always evident. If I can show you one example, um, let me see if I can find it. Yeah, over here. They've given you a question, let I is equal to this, and then they're asking you to use the substitution, and then you have to convert it into this format, and then you have to integrate this. So yeah, integration by substitution is always very evident because they give you this kind of a hint. But let's say if you're trying to integrate something and none of the rules that I've taught you above, none of the rules that I've taught you above works, then you can always try U substitution. But in my experience of P3 mathematics, they never ask you to do the U substitution by yourself. They will always give you a hint when you are supposed to do it. But yeah, as a last resort, you can always use U substitution if you are stuck and if you're not able to think about any other method but the U substitution. You can take a bet and try to solve it with respect to that. But yeah, I highly recommend that you should be aware about how to do the U substitution. Uh, yeah, if you are not aware about this, I'll give you an example. Just look into that video and get better at it. Okay, you can look at the type 5 video of this series in integration to understand this kind of question. And lastly, I'll also talk about area and the volume question is one of the important key pointers coming from your P1 concept. You know that the area under the curves is simply your integration, and volume of revolution is with respect to, again, the square of the function multiplied with pi, depending on if it's with respect to y-axis or v-axis. So I hope that the P1 concept is intact with respect to area and volume. And then in integration, we will just use the P3 integration instead of AS level integration in most of the cases while dealing with area and volume. And then simply you will have to integrate it with the rules that I've taught you over here, and eventually you will be getting your answers. Now it's time to look into the integration roadmap. This will be very easy to remember if you are aware about all the key pointers that I have mentioned over here. I have been recording the video for the approximately 30 minutes. So I hope that all the key pointers I have explained in detail. So now let's look into the integration roadmap. Always remember that there are two types of integration you will be getting, either in the multiplication format or in the fraction, that is the division format. If there is a multiplication format involved, always ask the following questions to yourself. Whenever the answer is yes, you know how to integrate it. In multiplication, the first question you need to ask to yourself is that is the given integrand in the format of f dash x into f of x to the power of n, or let's say f dash x multiplied with g of f of x. Because you know that after doing this kind of integration, in the division you will get f dash x, which is a variable. So if in the numerator already you are having f dash x, you can integrate the term which is not the f dash x and then cancel out the f dash x in the numerator and the denominator. This is valid. The example for the same I've already discussed over here. And when I give you the example of sine x into cos x. So that is the first question you need to ask to yourself when two things are multiplied, if this is the format. If the answer is yes, you know how to integrate it. But if your answer is no, most probably you will have to deal with integration by parts only. So just think about it. Is it possible that you can say that one is u, another is v, that is one is integrable, one is differentiable? If that is the case, directly go ahead and do the integration by parts. But after doing this, if you are getting again a repetition of doing the integration by parts, even this is fine. You can do double integration by parts in the same question. It will be slightly lengthy, but good enough for you to get the free marks by doing the same process again in the same question. That is the third question. Would repeated differentiation eventually lead to zero? If yes, use the integration by parts. Repeat as many times as needed. This is where, let's say, if you're getting x square sine x kind of a question, okay, what will happen over here after you do it by integration by parts? There will be a time uh, where you will get a format of x into cos x, if I'm not wrong. So again, you will have to do integration by parts, and you know that now this derivation of this will be 1. And after that, you will get integration of, let's say, something like sine x, and you know that one derivation is 0. So now you don't need to further take any derivatives. You can directly do the integration normally. So that is what I meant by this particular thing. But yeah, that is just the repetition of the integration by parts. Even this is one of the things you don't need to be like, shocked if you see something like this. You can keep on doing the repetitions until and unless you can solve the integration by parts and get the final answer. And then this kind of a question is also there. But so far, because I have not witnessed this kind of question in your P3, that's why I have not mentioned it over here. But you should be aware about this also. That in the repetitions, if your integrand is coming same as the question, then you can convert it into I and make I the subject of formula eventually. But let's say if you have asked all the questions and none of the answer is yes, if you are not clear about what to do, always think about U substitution method. This is a last resort, okay? And in P3, they will always tell you when to use U substitution. But yeah, still, as a best bet at the end, you can always think about a U substitution if none of this makes sense. Now let's talk about when you are having a division format. First of all, you know that this is same as writing u into multiplication of v to the power of minus 1. So you can think about that if I convert this into this format, that is a multiplication format, and then can I use any of this for given things to solve it? If the answer is yes, go with that multiplication format, or else you can talk about the division formats. The first rule in the division, apart from this, would be if the denominator is in the format of a square plus b square x square, and there is some kind of a constant in the numerator, think about the tan inverse rule. You simply have to think about the tan inverse rule that I have taught you over here. If that's not the case, think about f dash x over f of x rule. If even this is not going to help you, think about either the partial fraction or think about the long division method that I talked about in this particular question. Either of that has to work. If again nothing works, then eventually, if you're not clear, you can try U substitution as your best bet. And then some extra tips on top of this would be look at the patterns. If you're getting to integrate sec x cot x or sec x tan x, or let's say just the cos x square x or the sec square x, in the examination, how are these kind of questions asked? They'll first of all, let's say, ask you to take the derivative of sec x. You know that sec x is same as writing 1 over cos x. So they will ask you what is the derivative of 1 over cos x. And if you do the derivative, it will come out of all of this, it will be one of the answers. You can just do it right now and check it. So if I'm using the quotient rule of the derivative, derivative of 1 is 0. So 0 into anything is 0. Minus derivative of cos x will become minus sin x. So it will become sin x over here into 1 divided by cos square x. It's the same as writing tan x, sin x by cos x is tan x, and 1 by cos x is sec x. So 10x sec x is what you got over here. So now they'll ask you in the second part that integrate this. So you should be aware about that integration of the 10x sec x is nothing but sec x. So yeah, this kind of patterns are really important, that if in the question they're asking you to first of all differentiate and then integrate the result for the same, you know what is the answer. Then the second type of thing that you must have on your fingertips is, if you're having sine square or the cos square kind of things to integrate, you know how to use double angle identities and then integrate it. And if not clear at all what to do, even with respect to the trigonometric integrations, always think about the u substitution as your last resort. But yes, the u substitution is only to be done if none of these things are coming into your mind. But the chances are very high that you have missed out on one of the opportunities over here. You are not just able to relate it to the question. Because u substitution, they will always be telling you when to do it in most of the questions. So far, I have not seen a single question in which they are not mentioning that you are supposed to use the u substitution and then still you have to do it. I've never seen such kind of question. That is why think of this only as your last resort. U substitution is not something that you run towards in your P3. But if I talk about any other board apart from your Cambridge P3, U substitution is something that you have to do it by yourself. Questions do not ask you to do it. You should be smart enough to understand when you're supposed to use it. But yeah, that's not the case with P3 in Cambridge examinations. So you are good to go about it. But yeah, I hope that you've got the idea of the integration roadmap. Always look at the structure of the question, then try to match it with the pattern of the multiplication or the division. If none of that things work, you can think about the U substitution as your last resort and choose the most natural steps that comes to you. There is nothing like this method is true or that method is true. If one question can be solved with multiple methods, you can go with any of the method. As long as the method is correct, you will get full marks. So yeah, I hope this has given you some kind of an idea of how to be good at integration. And if you want to strengthen the concept, please watch the upcoming videos because there are 7 different types of questions, or sorry, I should say 8 different types of questions that I'll be solving. And on top of that, two unusual questions, as you can see over here, I will be solving it.